Welcome back in. I know people are getting their caffeine to get going. Great program so far today. My name is Michael Weber. It's good to see you. We'll be talking about powering the digital age, data centers, and energy supply. There's a lot of context. You already heard it from the opening speakers about what's going on in the energy system. You heard from Darren Woods a little bit about the moral imperative of expanding the energy system so that more people have energy access. And within that expansion will be significant expansion of the power system in particular. So one of the people I don't often quote, but I will quote him now, is Elon Musk. He spoke in Austin 2 years ago at the Edison Electric Institute conference, a big conference for power, and he was trying to explain to utility executives, you have no idea how many electric cars are going to sell. We need to double the system in terawatts and probably triple it in terawatt hours, and I think that's a very important growth in the power sector. And there are many reasons for that growth, but data centers are one of the causes of that, like the need for power for data centers, converting electrons into photons and useful bits of information that people can make money with or get some benefit to society. So there's this fundamental expansion going on that's pretty exciting. It's also something, if you look at the history of the power sector, we haven't had to deal with recently. It grew for about 100 years, then leveled for about 25, and now it's growing again. So we've lost some of the muscle memory how to grow, and it's pretty exciting to see that growth if you're someone who follows the energy sector or the power sector in particular, and it's exciting to see some of the applications. So we've got a great panel of people who can share insights on that. Immediately to my left is Michael McNamara, CEO and co-founder of Lancium. Lancium is ahead of the curve. They've been on this, the company is 8 years old now, I guess, right? So a lot of people talk about it now, but they were talking about it before, so they're ahead of the curve, and he'll share some perspective of what it takes to actually build the systems and the facilities to meet the moment. We have Doug Lewin here, who is associate professor of practice, is that right, at the OBJ school? But also has the, it's what they say, they'll say anything, they'll let anybody teach is what they say. He has the Energy Capital podcast, so if you follow energy news, his podcast is one of the ones that's become kind of the go-to for everything going on with energy in Texas. So one of the great sort of analysts and commentators and observers and almost a futurist now. You're trying to see what the trends are going on. So we got Doug talked about as well. And also Lisa Martin. She's the Chief Operating Officer and Deputy General Manager of Austin Energy, one of the biggest and most important municipal utilities around. And Austin Energy, as electric utility serving the tech sector, has a front row seat to a lot of this. So we get a lot of insights on what will be happening. And I like to say with Michael and Lisa, two people who actually do things. They have to build stuff to make it happen. And then with Doug and me, people who don't build things, but we talk about people who build things. So we've got some commentators and some real people. And I think that mix will be really useful. And we'll just go down the line and let them offer some insights about what's happening, and we'll have a little conversation about that. So really appreciate you being here. And Michael, we'll start with you.
Thank you, Michael. I'm the CEO of Lancium. We started the company 8 years ago with the thesis that a grid that would absorb a lot of renewables would have an interesting feature, which would be pools of negative priced energy. And the thinking was there will be a tremendous load growth across industries that you just mentioned, Michael, and could we find the best places to take advantage of that feature and utilize that energy? And what's apparent now is that all that energy should go to AI data centers, at least the projects that we build, which are all in Texas. Project one is the Stargate, which you may have seen in the news, which is in Abilene, which is 1.2 gigawatts, fully under construction, fully financed. We own a thin layer. We are the landowner. We build all the electrical infrastructure and own it. And then we will also build probably the country's largest solar project and the country's largest battery to accommodate the power needs of the Stargate project. It has two interconnections, one to the 138 system and one to the 345 system. The reason we went to our locations in West Texas was the CREZ system was built in 2014 as a highway to move renewable energy from the Panhandle in West Texas to the load centers in Dallas, Austin, and Houston. And our idea was, well, if it's an on-ramp for generation, it can also be an off-ramp for load, which is where we are in very critical junctures. A lot of the things about the project are kind of bonkers. It has its own concrete plant, its own asphalt plant. 6,000 people are there now, working every day. We ended up stressing the county roads to such an extent that we built our own 7-lane highway inside the campus that accommodates the people coming in and out. Without commenting on economics, if you were to do the arithmetic on a project at the scale, you'd see something like at full scale, it would consume $75,000 of electricity every hour and produce $1 million of revenue every hour, every day, every week, every month for many years. So the very large scale, we got feedback from the first hyperscaler in 23 of maybe we could build a gigawatt data center. That bogey is now 5 gigawatts at a location, which is very hard to accommodate. And so what we'll announce next month is a plan with AEP to build a new ultra-high voltage system in the Panhandle that connects to the ultra-high voltage system being built to accommodate the Permian. And so the absolute key is if you build enough generation, enough wires, and interconnect them in the right way, you can accommodate projects of that scale. And that would take the Stargate campus to 10 square miles of data centers, 6 gigawatts of peak demand, which is 2 Austins. But that's what we see coming, and that's what we've been building.
I think the scientific term you use is bonkers.
Yes.
This is just bonker. Like it's hard.
It's a unit.
It's a unit. Yeah. So it's 5 bunkers big. I mean, so let me put some scale on it. 5 gigawatts. That's like 5 nuclear power plants. That is huge, right? Just about that is almost 2 Austins in one location in terms of power demand. You talked about 345, that's 345 kilovolt system, so that's a transmission line system for those who aren't in the power sector. CREZ, the Competitive Renewable Energy Zone. We made decisions, I don't know if you guys are familiar with something called bipartisanship, but we used to do that. But we had this thing in Texas where Democrats and Republicans came together and said, hey, let's expand the transmission system. They called it CREZ, Competitive Renewable Energy Zones, to move power from renewable energy-rich areas to load centers, which we were thinking like Houston or Austin. But now those load centers might be a data center out west. So we expanded the transmission system to great economic benefit. So you're able to leverage that, and maybe there'll be more of that. So the scale's enormous, right? I love your own asphalt plant, your own cement plant. So it's real, it's happening in Texas. Of course it's happening in Texas, everything happens here. So it's great to hear those numbers. Doug, what are you seeing?
Yeah, so I think my role here is to do a little bit of Texas boosterism. I really do think Texas is the place we are going to see this AI data center build out. Not that it won't happen other places. Obviously, Northern Virginia is an area where a lot of data centers are being built, and there's other hotspots around the country. But I just don't think any other state has the mix of the natural resources, the sort of policy and governmental bent to kind of like enable business and entrepreneurial activity and kind of stay out of the way, not put up a lot of permits and red tape like a whole lot of other states do, and then a competitive market. And like you put those things together, and I really do think Texas is the place this is going to happen. Obviously, there's a lot of discussion throughout all the different panels on data center, right? You almost can't really have a discussion about energy without talking about data centers. So I do think it is very important to reframe a couple of different things here that I'll just try to do at the outset here. Number one, we're almost always talking about this stuff in terms of gigawatts. We're on the wrong scale. We have to start thinking in terms of terawatts. If we're not thinking in terms of terawatts, we're doing it wrong. I see increasingly, I might add to my bio, almost a futurist. I really like that.
Futurist adjacent, we might say.
Futurist, almost. I really like almost a futurist.
Yeah.
It's kind of good. Yeah. I really like that. But like we do need to think like on the, in the late 2030s and the 2040s, if we haven't built out terawatts of power to accommodate this, our country's not going to be in a good place. Like we have to be able to develop AI here. And I really think that is the scale that we need to think about. But I want to reframe it a little bit further. Terawatts and terawatt hours. You talked about doubling terawatts and tripling terawatt hours, something Elon Musk said. Let me just see a show of hands here. You guys play along with me here. How many people know what the peak demand in ERCOT is? Don't worry, I'm not going to ask you. I just want to know if you've heard the figure, have a pretty good idea of what the peak demand in ERCOT is. So a good number of hands, maybe a quarter of the crowd. How many know how many terawatt hours Texas consumed last year? 1? So this is a problem, right? Because everybody is so fixated on peak, and that's not a bad thing. Like we need to control the peaks, of course. But we have so much slack in the system. So let me drop a stat on you. The peak demand in ERCOT is 85.5. We hit that 2 years ago.
Gigawatts, 85.5 gigawatts.
Excuse me, gigawatts. That's the peak demand. Didn't hit that in 2024. We got close, like 85.2 or something. This year, we maxed out at about 84.3. So there has not been peak demand growth in 2 years. During that time, our terawatt hour consumption, our energy consumption, has gone up nearly 15%. So every single month this year, we've used more than last year, but peak demand is not higher. The last 3 months, all summer long, the minimum usage in Texas is way up, 5, 6, 7, 8% year over year. Our maximum use is not. That is a good thing. That is a sign that data centers are starting to come on and do things that are flexible, moving away from peak and filling in the valleys, using more power when there's enough of it. So this is really where I do think this is going to happen in Texas for the mix I described earlier, like low regulatory burden, not a whole lot of permitting, a competitive market, which hopefully we'll have a little bit of time to talk about more, and great natural resources. I think we're going to see this stuff built here, and I think like within our lifetimes, we're going to see a terawatt scale grid. And I think that's a great thing for the state. I think it can be a really good thing for consumers. I hope we have a chance to talk about that later, and I'll stop.
That's great. Just to put some other numbers on that in context. 85 gigawatts peak demand in Texas, about 10 times more than that peak demand in the United States. So knocking on the door of a terawatt. We're talking about adding another terawatt to the United States, maybe a terawatt in Texas or something like that.
Yeah.
Texas is 400.
It's ambitious, but
yeah,
you know.
It's
yeah.
a lot.
So on terawatt hours, by the way, I didn't say that. We were 460 last year. If we, the next 4 months, use what we did the first 8, we'll be at about 485, 490 terawatt hours. So almost 500 terawatt hours compared to 400 4 years ago. It's a 25% growth in only 4 years. That we haven't seen that maybe the late 1970s, but probably more like the 60s last time we saw that kind of
Means the nature of how we're using electricity is different, and you heard some of that from Michael as well. So another statistic is we use our multi-trillion-dollar power sector about 50% of the time or less. And if we increase the utilization, that should lower costs for everybody, although people are cost conscious and nervous, as they should be, which makes sense. Lisa.
Yeah, so as an electric utility person, I love how you go way back to, we should be talking about terawatts, and we should. But I also get to the real practical aspect of it and start thinking about, in order to bring on every load, you have to have a point of interconnection, get exactly and make sure you can meet that load exactly where it is. And so, you know, whether you're a 3 gigawatt system like Austin Energy or, you know, much larger, these loads that are coming in at, you know, a gigawatt or more, you said 5, right, create a lot of challenges and a lot of opportunities. And when I talk to my utility colleagues across the country, everyone is approaching it in different ways and has, some people love the idea and some people are just, it's terrifying because the challenges are very real. And what we're talking about is making sure that, you know, there's enough space on the transmission and distribution system to serve that type of load. Is there sufficient generation? And frankly, in many places there's not at the times you need it, so then how can you control the load as appropriate? And so in order to build out those things, it takes, you know, sufficient supply chains, and the tariffs are adding added complications to things. It becomes a real challenge, and when you know, meeting these large loads is a huge priority, and serving them as a utility, but also the speed at which that the need is there is it's not that you don't want to, it's just a matter of how feasible is it. So really resetting expectations, looking for creative and innovative solutions, and then also managing that along with other priorities like extreme weather and wildfire risk, changing energy landscape, trying to make sure that our costs remain affordable and we don't have stranded costs for our customers. These are all areas that I'm just kind of glossing over here in this intro, but there's deep components to every aspect of it, and not to mention making sure that the grid remains reliable along the way. So
yeah, it's not just expanding. We must operate it in a warmer world, and that warmer world in Texas means more heat waves. It also means more cold snaps in the winter, which is very non-intuitive, and maybe more windstorms, more drought, therefore wildfire risk and everything else. Now, while I've got you, Austin Energy is not new to growth. I mean, we talk about, oh, the power sector's got to grow for the first time in decades, but Austin Energy's been growing for the last several decades. Can you talk about the growth already? And you already have IT and some factories and data centers. So what has the growth been like in Austin, and how has Austin managed it? Looking backwards, how might you manage it going forward?
Yeah, so it's you know, a fair amount of commercial growth, but also population growth. People wanting to move to Texas, people wanting to move to the Austin area and the surrounding areas. You know, as we look forward, actually, one of your students did some analysis. Actually, both of your students did some analysis for us, and a lot of electrification, a lot of electric vehicles, and so managing and maintaining the grid so that it can support those needs in addition to the large load becomes a real balance.
I think you're right. So demographically, the driver of growth has always been people, more people who want electricity for their homes to cool their home or heat the home and everything else. But now we're adding on top of the more people, data centers or other new devices people own, like electric cars, induction cooktops. And that analysis reference to the student, Emily's Arnhem, who did it, we found like data centers are cool. They're very exciting. They're a very wealthy customer. This is great. But if everyone buys an electric car and plugs in at the same moment, that would be very difficult for the grid. And therefore, we should not all plug in our electric car at the exact same moment. We should probably spread it out. So there are things we need to be mindful of.
Or
in addition
plug
to
it in
this.
at the same moment, but have software that manages when it's charged.
Some intelligence that manages the charging,
If
exactly.
only we had like artificial intelligence that could coordinate.
Or smart devices or something in telecom. Yeah, they're all these great. Someone should invent that because that'd be really handy. So I think thinking about the nature of the loads and who it is and everything else. So Doug, you mentioned consumers. You care a lot about consumers. What are some of your thoughts on that? You think about rates and costs or total bill?
Yeah.
Electricity affordability crisis is like a tagline I'm seeing a lot now.
So you were talking earlier about 138 and 345 kV. The legislature the legislature passed a bill that paved the way for the PUC to approve the first 765 kilovolt lines ever in the state of Texas. They're going to start being built out to the Permian, by the way.
And just in electrical engineering speak, that's really awesome. Like to do higher voltage means more throughput, more efficiency, more capacity.
So much more potential to move power around. I'm very excited about that happening. It's expensive. It's going to cost $15 billion, and that's only half the plan we need. So how do you pay for that? You have to be able to spread that cost around to a lot more customers. Luckily, there's a lot of customers coming. Stargate is one of many. It's probably the most exciting project in the state right now, but there are many others that are coming. There is a way to do this, and the PUC will be looking at it over the next year of how do we do transmission cost allocation, spread those costs over a wider amount of customers. And we won't have time to get into this in depth, but if anybody's interested in it afterwards, please find me. I want to talk to anybody that wants to talk about this. I think the next frontier of competition, I'm very excited. Again, like I said, one of the reasons I think Texas is going to lead this not just this country, we'll definitely lead it within the US, but I think we're going to lead the world on data center development is because of the competitive market. Competitive market is amazing for wholesale. We have seen fantastic benefits from that, and I could talk about it all day long. Retail, I think we're really starting to see with this new wave of innovation of Octopus and Base and David Energy and Tesla has a retailer and on and on and on. The retail market is, I think, at that point in the curve. The next frontier, as far as I'm concerned, is the demand side, the distribution side. And how do we actually set up markets there that actually pay entrepreneurs they can then monetize the reduction that happens at peak. Again, we want more kilowatt hours consumed, that's good. Transportation, more air conditioning because it is getting hotter. We're going to need a lot more air conditioning. Like more energy use is good. All those vehicles plugging in at the same time and charging at the same time is bad. So how do you actually create markets that actually send a signal, right, to somebody to like, don't charge that car now, charge it 1 in the morning. The beginnings of that are in our competitive market right now, but we need to go much further. And I think if we can do those two things, make sure we get the transmission cost allocation, spread it over a much wider customer base, so data centers are paying quite a bit of that because they're going to benefit a whole lot from it. And then also make sure that we enable these distribution markets so that end use customers can actually be paid for their participation. Always voluntary. Customer doesn't want anything to do with it. That doesn't matter. That's okay. That's fine. That is how markets work. Customers have to have a willingness to participate. You can't make them buy or opt in or anything like that. It's totally voluntary. But if you decide you don't want to do it, but your neighbor does, you still benefit from that because that's competition. That's more energy resources in the grid. So I think those couple of things, really getting more energy efficiency, demand response, distributed energy resources, EV charging, and having a price signal so that we can really, instead of kind of bumping along like we've been doing, really scale that up. That will be a big boon, not only to lowering costs, but actually to putting money directly into customers' pockets for participation.
Well, I say as a Texas native, I appreciate the Texas boosterism. As an Austin native, I appreciate the Austin boosterism. And Michael, you're in Texas for a reason. We were talking beforehand. You said, yeah, we're not dealing with the FERC, the Federal Energy Regulatory Commission. We like Texas. Can you talk more like why Texas? And do you see more growth beyond just this one? This project's huge. You're doing the 5 bonkers project, but do you have more projects? Why Texas? What's some of the growth potential you see just within your world?
Yeah, so I think Doug's exactly right. The competitive market is key for us. Texas is very blessed with the best natural gas basins in the country and also the best solar and wind resources and the best place to build. And ERCOT is the best ISO, the interconnect and manage, which allows you to build quickly. In regulated markets, the Utility Commission and the governors and the utilities have very difficult decisions to make. I know the state near here, the governor said, we want to be a home for AI data centers. And they asked the regulated investor-owned utility, what would it look like for us to accommodate many gigawatts? And the investor utility came and said, we can do it. It will take the rate base from 9 billion to 90 billion. And the governor said, and if the data centers don't come, then retail rates go up 10 times. So what is the right answer? And I don't know what it is for them. For us, we submit interconnect requests for load, generation, simultaneously that all match and pair on dynamic studies, on stability studies, and on resource adequacy. And we'll go do it ourselves, and the wires get built, and they all get interconnected, and you can do it much faster. And if the volumetric use shows up from the data center, it causes a net reduction in rates on T-costs to every consumer.
My hypothesis, which I've not done the analysis to support yet, but which I believe firmly, so I know this is recorded, we'll come back in a year or two, see if I was right, is if we build a lot of data centers and it drives up demand, but also drives up consumption in the terawatt hours, and they're flexible, it should lower cost of service for everyone. Now, that doesn't mean it will in the short term. There's this tension about, oh, there's new customers, will that drive up the price for retirees or grandmothers or certain businesses? But if we do it the right way, it should lower cost of service. That's what I optimistically hope, but we don't have the analysis on that yet. But it reminds me a little bit of the fracking boom 15 years ago, where there was so much competition for water, and prices for water went up. And people were very mad at hydraulic fracturing for using so much water. And if you look on an average, hydraulic fracturing was like 2% of the water use, so it wasn't a big deal on average. But in that county, it might be 100% of the next water. And that's the way it feels for me with AI centers is actually on average, it's a couple percent of electricity consumption, not that big a deal. But it's 100% of the next kilowatt or kilowatt hour that's available. And so in the near term, that drives up prices for water or electricity, if it's fracking or AI. But in the end, it leads to investment in more water resources and more power, prices settle back down. So I wonder if we're in something like that. I know there's a lot of price sensitivity. It is different to have a very wealthy customer, a hyperscaler come in who's bidding for power in a way that oil and gas was a wealthy bidder for water. So that does change the market, makes people nervous. So it's worth doing it the right way so it doesn't drive up costs for everybody, I think. On that, I think like Austin Energy, you're community facing, you're part of the city, your customers are your owners and your bosses and all that kind of stuff. And I've been watching Austin Energy closely for many, many years as a native and a customer and a former commissioner and everything else. One thing I've looked at is your workforce has changed also. I think, are you up to 1,800 employees or something like that?
I think 1,900.
1,900, and it used to be like 30. So you're growing, the utility grows along with the people, but maybe not quite as fast as the city. What is your workforce like? What kind of people are you looking to hire? And I'm kind of curious, is UT training the right kind of people you need?
Yeah.
And maybe this would be a question for Doug and Michael. Like, are there a lot of students in the room who might be looking for a job? What should they know? What are you looking for? What is the workforce gonna be like?
It's a really great question and something that is an additional constraint for a utility trying to meet all the needs. But we, highly specialized engineers, but honestly smart students who are willing to learn and grow because there's so many different facets. But also in our energy markets office as well, that's another area that's particularly challenging to find parts, and even in our regulatory and policy space, because all of these areas are moving and changing so rapidly at the same time, and there's a Venn diagram, a sweet spot where it really helps support the utility to ultimately serve the customers in the community to help us balance their values of reliable power, affordable power, and clean power all at the same time in an equitable way.
All that in its growth mode. And I don't want to make it sound like the utility sector is not innovative. I think the utility sector is very innovative now, but that's not what people thought 15 years ago.
Right.
15 years ago, my students were like, I want to go to Google, or I want to go to, they seem very high tech. But now the students are saying, actually, electric utility space looks really interesting because that's where a lot of the innovation is, where a lot of investment is, where a lot of the growth is. So hopefully we can get you more people you want to hire. And just the numbers, I'm going to be wrong on the details, but I'm roughly correct. We're missing like 100,000 electricians nationally. We're missing like 100,000 pipe fitter. Like the number of people we need to build the power sector, the pipelines, the data centers to meet the moment is a lot. But then you go down a level to just the grid planner. I think there's like 1,000 grid modelers or grid planners we're missing, which you need for interconnection studies, for permissions, for rate case, all this. So there's a lot. We need to train up more, and it's something we need to think about.
And to run and operate the power plants and to maintain the grid along the way as well. I didn't talk about the folks that are in the field.
All of that.
All of it.
So Michael, I think you said 6,000 people at your site. Were you able to get, do you need 7,000? You had to stop, could you find what you needed, or how did you do that? And what are your workforce challenges looking forward?
So we as just the infrastructure provider, we lean heavily on our EPCs, which are Mortenson and Quanta Services. So our workforce is primarily engineers in the head office that manage all the vendors and EPCs. Crusoe is building the data center with DPR, their general contractor. And I think they have electricians from every state in the country. There are RV parks and man camps. Every hotel is sold out. And we know of other similarly sized projects very close by. And so the labor force will be very challenging. But the oil and gas industry has done it on offshore oil rigs in the North Slope of Alaska. And so it's a challenge that can be managed, but there's absolutely going to be increasing demand for more technical trades that can end up being really great jobs. And I know our EPCs, Quanta Services has a whole campus in San Antonio, and Mortenson Begins Middle School reach out to do introduction to mechanical and electrical engineering. And so they've been recruiting early because they see it coming too.
There might be a fascinating shift just demographically or generationally with what people want to work on. There was an article in the Wall Street Journal maybe a year and a half ago about the tool belt generation. I don't know if you saw that, about how more and more 18-year-olds say, well, maybe I'll go get a job that pays $100,000 a year rather than going to college and paying $100,000 a year. So there's been a shift among potential students, but also parents they're pulling, well, my kids are all college kids and I'm a college kid, so my family likes college, but more and more parents don't think college is worth the money. So there might be a couple shifts and the workforce might not be. So we at UT need to think about as professors, okay, what are we teaching or training? How do we modify or adapt as a university? Because there's such a growth trajectory, and we need to make sure that the value stays there, that people get what they need out of college, or that the workforce can be filled in the way you need. So Michael, you said something in your opening comments about you can convert $75,000 electricity into $1 million, or your tenants or your customers will. And I think about the value of electricity. I think that's like semiconductor manufacturing does something kind of similar. Most of us pay our 10 or 12 cents for a kilowatt hour. We don't turn it into 10 times the value. Most of us are using it for air conditioning, which is very comfortable, but not necessarily lucrative. And so I'm trying to think, what are some of the valuable uses of electricity? And maybe Lisa, I'll start with you, because you have a lot of customers you serve. But electricity is really valuable. What are some of the ways you see electrons being used that people convert into money or benefit or other things that we need to keep an eye on?
Certainly you talked about the semiconductor industry, right? I think that they're also using electricity to power, we talked about electric vehicles in a number of different ways. And I do think that the data center component of it is real. We are not talking about a gigawatt at a time that we can serve in Austin, certainly with our current infrastructure. But we're seeing ramp-up rates that start in the tens and then go to the hundreds. Sorry, to enable those industries.
Yeah. So what are some other uses of electricity you see coming that aren't on our mind right now?
Well, so I love this question. So I mentioned earlier the 765 kV lines, right? One of the main backers of that was the oil and gas industry, right? The Permian Basin Petroleum Association was really big on that. It was House Bill 5066 that required ERCOT to change the way they did their load forecast. It passed in 23. People didn't quite know the data center thing was coming. They were doing it because we knew it a little bit, but not as it's become 2 years later. But they knew they had done this six of the biggest oil companies in the Permian. Some of them have merged. Pioneer and Exxon were among them. Diamondback, Chevron, et cetera. They hired S&P Platts to do this study of like how much power would they actually need. They're using something like 3 or 4 gigawatts of grid-connected power, but their demand is like 10. There's just a whole lot of diesel gen sets. It's a very inefficient way to run a fracking operation. They are trying to connect to the grid as fast as they can. So, look, if there's one thing, hopefully, that I leave you with, there the stuff that is going on right now nationally, and in some states, I knock on wood, is there wood around here? I don't see it as much in Texas, I hope we never get it, that it's this oil and gas versus renewables as some kind of death match. This is stupid and counterproductive. Okay, so like I was in Houston the other day, Houston Energy Transition Initiative, their tagline is more energy, less emissions. Like, think about that. Like, that is what Texas should be. Doesn't mean there's no oil and gas. Of course not. That would be a ridiculous worldview. Like, look at how much oil and gas is being used and what it's being used for. Can we produce it with less emissions? One way to do that is to connect it to the grid, electrify fracking operations, right? We are electrifying industrial applications in Texas. You were my third podcast interview. The first one I did was with Will McAdams, former commissioner, and I asked him what kind of he learned coming out of Winter Storm Uri, and he was like, one of the things was we didn't quite have a grasp of how many industrial customers were already electrifying some of the lower heat stuff. But as we get better at this, the higher heat stuff's going to electrify too. There's going to be all kinds of electrification. Molecules and electrons can coexist. And I'll leave with this. I said we need to think on a terawatt scale. The projections out of like IEA and others are that the United States is going to go from like the 1.2 terawatts we're at now to like maybe 2.2, somewhere in there. China's going to go from 3 to 8. If China goes from 3 to 8 and we go to 1 to 2, this is the Chinese century, not the American century.
That means we lose, yeah, basically. And that's a race that we don't want to lose for sure. Oil and gas is important because oil and gas demand for power might be the same as AI in Texas, but doesn't capture the headlines the same way. First of all, it's a different kind of customer. It's not as loud about it. But the electrification of oil and gas reduces emissions, reduces noise, improves safety. Every diesel delivery truck is an accident waiting to happen, so getting off the diesel generator is handy. And you go to these downhole electric submersible pumps that improves your productivity. So electrification of oil and gas it's a real customer paying real money to improve operations, and there's a lot of growth there.
The far west zone in Texas has tripled in the last 8 years. Energy consumption has tripled in 8 years in far west Texas.
Yeah, and it's a mix of primarily gas, wind, and solar as you expect elsewhere. Michael, what are some of you think of future of electricity, what are some other, you're already making a ton of value going from electrons to photons for data centers. What are some other uses of electricity you see?
Yeah, what we're seeing from our customers and their downstream customers, I mean, it just looks like the demand to put electrons through circuit boards is unstoppable. Mm-hmm. So that's going to be our focus. When you look at potential for electrochemistry, if you're going to have 100,000 robots on an assembly line, you're going to talk, a similar scale as a AI data center. And I think to Doug's point, the more power you have, the more effectively you can move it around at reasonable rates will unlock demand that we don't even know yet.
There's a lot like robotics. I love that you said that. Electro-smelting, electro-refining, electric vehicles, you already heard, heat pumps. There's a lot of demand. And in Texas, if you look at the forecast of what will be built in Texas to meet that load, it'll be a combination of wind, solar, and gas. I think we kind of know what needs to come.
Yep.
And storage will be a great tool to help out on that. So that's probably come to Texas to see the future. And so for anyone not from Texas, take the message back to wherever you're going. Anyway, please join me in thanking this panel for this excellent discussion. A really great conversation. Thank you.